Quantum computing is one of the most exciting and misunderstood technologies emerging today. It's not just faster computing, it's a completely different way of solving problems that were previously impossible. In this video, we're diving into how quantum computers work and why they could change everything from medicine and material science to artificial intelligence. Let's get into it. To understand quantum computers, let's start with the computers we use every day, classical computers. They process information using bits, which are binary. They're either a 0 or a 1. That's like a light switch, on or off. But quantum computers use qubits, and qubits are different. Thanks to quantum physics, a qubit can be in a state of 0, 1, or both at the same time. This is called superposition. It allows quantum computers to process massive amounts of information simultaneously. Think of it like reading every page of a book at once instead of one page at a time. That's the power of superposition. And there's more. Qubits can also become entangled, meaning the state of one qubit is linked to another no matter how far apart they are. Changing one instantly changes the other. This is called quantum entanglement, and it's another key ingredient in quantum computing. Quantum computers are incredibly sensitive machines. Most of them operate at temperatures near absolute zero, colder than outer space. To keep qubits stable, instead of using classical logic gates, quantum computers use quantum gates to manipulate qubits. These gates rotate qubits on a complex mathematical plane, allowing them to perform computations that scale exponentially as more qubits are added. But qubits are fragile. They can lose their quantum state due to noise, heat, or interference. That's why quantum error correction is one of the biggest challenges scientists are working on. We're still in the early days, called the NISQ era or noisy intermediate scale quantum. But progress is happening fast. One of the most promising uses of quantum computing is in chemistry and medicine. Quantum computers can simulate molecules and chemical reactions at the quantum level, something classical computers can't do efficiently. This could accelerate drug discovery by years. Imagine finding cures for diseases like Alzheimer's or Parkinson's in a fraction of the time it takes today. Google, IBM, and biotech companies are already using quantum algorithms to model proteins and optimize chemical compounds for new treatments. Quantum computing could also unlock new materials. From superconductors to advanced batteries, simulating atoms and molecules accurately means we could design materials that are lighter, stronger, and more energy efficient. Want better solar panels? Quantum computers could help design them. Need batteries that last 10 times longer? Quantum models can guide the innovation. Artificial intelligence is also on the verge of a quantum leap. Quantum computing could supercharge machine learning algorithms, allowing AIs to learn faster, make better predictions, and analyze massive data sets more efficiently. Companies are already experimenting with quantum machine learning, which could lead to breakthroughs in fields like finance, climate modeling, and personalized medicine. Now, it's not all solved. Quantum computers are still in development, and scaling them up is incredibly hard. Noise, instability, and error rates are still big hurdles, but advances are coming fast. Major tech companies and startups are racing to build quantum processors with more qubits and better stability. And yes, you can already access some quantum computers through the cloud. IBM, Google, Amazon, and Microsoft are all offering access to researchers and developers. quantum computing isn't just hype, it's real and it's coming. It might not replace classical computers, but it will work alongside them to tackle problems we could never solve before. So, whether it's curing diseases, discovering new materials, or enhancing AI, quantum computing could be the key to our next big leap. If you found this video helpful, give it a thumbs up, subscribe, and hit that bell for more deep dives into future tech.